Hello, today's video is going to be on solving by factoring. We already have reviewed factoring, so now we're just going to take it one step further. And actually, you already did solving when we did intercept form and then we found the x-intercepts. It's actually one less step than finding the x-intercepts. So the first kind of factoring is GCF factoring. Remember, you look to see what the two things have in common. Between the 6 and the 2, they can share a factor of 2. We've got an x squared and an x, so I pull out an x. We divide that out. So 6 divided by 2 leaves you with 3. X squared, take one x out, you've got one x left. A negative 2 divided by 2 is going to be a negative 1, and you took out the only x. All right, so now that we have it in completely factored form, now we're going to solve. To solve, you set each of those pieces equal to 0. So we have 2x equals 0. We divide by 2, and we find that x is going to be equal to 0. That is one of our solutions. When we looked at this before, we took that and we put it in intercepts, but now we just want the solutions. We take our 3x minus 1, set that equal to 0, add our 1 over. 3x is equal to 1, we divide by 3, and we find that x is equal to 1/3. So we have x is equal to 0, or we have x is equal to 1/3. Those are our two possible solutions for that quadratic. The next kind of factoring that we talked about was the difference of two squares. We know that we're going to solve. Maybe you're like, well, how do I know if I'm going to solve or I'm just going to factor? We know when we're solving because we have an equal sign. If we don't know what something equals, then there is no way to solve for what x is going to be. Now difference, don't forget that difference means subtraction, and you need two perfect squares. Don't forget that's going to be a 1. 1 is a perfect square, 4 is a perfect square. When you set this up, you've got your two sets. Take the square root of the first piece. The square root of x squared is just 1x. The square root of 4 is 2, and then you make one of them a positive and you make one of them a negative. So that's our quadratic in factored form. And we're going to use that factored form to solve. To solve, we're going to set each of those pieces equal to 0. So we've got x plus 2 equals 0. We move that 2 over. We have x is equal to a negative 2. We set the x minus 2 equal to 0. Move that 2 over. And we have our second possibility of x is equal to a positive 2. After that, we talked about regular factoring. So when you have regular factoring, you've got regular factoring, you have Batman factoring. Your regular factoring, think about you have a trinomial, ax squared plus bx plus c. You use regular factoring when your a value is 1. Batman factoring is what you do when you have that trinomial and your a value is not equal to 1 after you have pulled that GCF out. So maybe you start with something that's not equal to 1, but if you pull the GCF out, it becomes 1. You would still do regular. So it's only if it's not 1 after the GCF has been pulled out. All right, so when we look at our regular factoring, there's an issue we have here. My problem is it's not set equal to 0. When you're setting each piece equal to 0, if you remember, it's called the zero product property. You can only solve when factoring when you have your trinomial set equal to 0. So if any time it's not set equal to 0, you're going to move it all over so that it is set equal to 0. For regular factoring, you're looking for two things to multiply to the outside and then add to the middle. So the two numbers that are going to multiply to a positive 25 but add to a negative 10 are a negative 5 and a negative 5. Negative 5 times a negative 5 is a positive 25. A negative 5 plus a negative 5 is a negative 10. Now, unlike the difference of two squares where we had one positive, one negative, these are both negative. So I'm going to rewrite this as x minus 5 quantity squared. This is what we're going to reference later on as a double root. It's strange because it's going to count twice later on down the road because it's going to hit it twice. So we have x minus 5 quantity squared. It's going to count as a double root. So we have x minus 5 is equal to 0. We move our 5 over. So we have one unique real solution at x equals 5. All right, and then our last kind of reminder of factoring is Batman factoring. So we have the same issue starting here, is that it's not set equal to 0, so we move that 16 over. We get 5x squared plus 38x minus 16 is equal to 0. We check for a GCF. There is not a GCF between these three terms, so we go ahead and start Batman. 5 times a negative 16, that's going to be a negative 80x squared. We pull down that first term of 5x squared. We pull down the last term of a negative 16. And then remember the Batman wings, we are multiplying to the negative 80x squared, and we're adding to the positive 38x. Those two numbers happen to be a positive 40 and a negative 2. So 40 times a negative 2, negative 80. 40 minus 2 is a positive 38. And if you remember when we learned about Batman factoring, we showed how it doesn't matter if you put the 40x or the negative 2x first. In the end, you end up with the same two factors. So at this point, we have our pieces broken down. We are going to now factor by grouping. We group the first two together, we group the second two together. Looking at the first two, we're going to pull out that GCF of a 5x, which leaves us with x plus 8. We look at the second piece. Don't forget that that x has to be positive. So I'm not just going to pull out a 2, I'm going to pull out a negative 2 to make that a positive 1x and a positive 8. Hopefully you remember that we are looking for these two pieces to be exactly the same. Remember, if those aren't the same, then you Batman factored incorrectly and you want to start over. We take those two GCFs that we pulled out, we combine those together to be our first factor. That same piece from the inside, that x plus 8 becomes our second factor. So we have our quadratic in factored form. Now we're going to use the zero product property to set these pieces equal to 0 and solve. We move our 2 over, we divide by 5, and we find that x is equal to 2/5. Our second piece, we have x plus 8 equals 0. We move our 8 over, or x is equal to a negative 8. So you factor. Once it's in factored form, you set each of your pieces equal to 0 and solve. So it's just like intercept form when you were finding those x-intercepts, except for you actually do one less step because you don't put it in coordinate form. Okay, and that is it for our learning how to solve by factoring video.